I'm Richard Roth with A and Roth Company. We're a Louisville-based heating and air conditioning company that specializes in geothermal and radiant floor heating. We're on a new construction project, so you may hear some noises in the background because they're actively working. And we're going to talk about duct systems today. So this particular house has got a geothermal system that'll have multiple zones. So there's different ways to do zoning. Most people think of a zone as a HVAC system with its own ductwork and its own equipment. Another way to zone is with mechanical zone dampers. So in this application, you use one piece of HVAC equipment. In this case, it'll be a water furnace geothermal unit, and we can have up to 6 different thermostats on this system. In this configuration, we're going to have 5, and you can see that each zone is represented as its trunk duct. So the trunk duct is a square duct that runs down where the branches come off to hit the different registers. When you are doing a zone system, a couple of things are very important. One is that you seal the duct system, because when you only have one zone calling, you will increase the pressure in the duct, so any leaks that exist will be exaggerated and be even more leaky. That would make for uncomfortable basements that are already going to be cold just because the cold air wants to fall. The other thing that you want to do is you typically are going to oversize the trunks. So you have to find out what is the lowest airflow that the unit you're using will run on, and then you try to size your trunk duct to be able to accommodate that low airflow. So that differs in a normal HVAC system, because in that case you just have a lot less duct. But you can see from this system that there's obviously added cost involved with this, because there's a lot more material, there's a lot more labor, but the value is long term, you have less equipment to maintain, less equipment to replace, and it's a more elegant way to push energy around. So in this particular house, it's ICF. An ICF house is inherently very efficient. It doesn't need very much air conditioning or heating to be able to condition it. But the problem with that is if these homeowners decide to have a big party and they load it full of people, they want to be able to air condition it. So with a zone system, it gives you the ability to shift the energy where you need it. So in this configuration, if they're having a party, they can turn that area down, but they're not necessarily overcooling the bedroom or the basement to be able to accommodate that extra capacity or that extra need. So like I say, just trunk and branch duct system, sealed up, and five zone system.
So Richard, what are we looking at up here in those little washers or screws? What are those?
Right. So when you talk about a 90-degree turn on a piece of duct, most people want to think that a duct fitting that has a round back or a radius back or throat on it would be more efficient. But actually what we find is that if you put turning vanes in the duct system or in that turn, it greatly reduces the friction of the air trying to go around that turn. So that is turning vanes, which is essentially just pieces of metal that are curved, and there's a series of them. So as the air is coming down the chute, it helps direct it where we want it to go.
That improves the airflow without the need for making radial turns and sweeping longer turns.
Correct. So a normal square-backed elbow, I believe, is somewhere around 30 equivalent feet of duct. So, each one of these sections of duct up here is 4 foot long. So just putting a 190-degree turn with no sort of turning vanes or anything is basically like adding 30 sections of that straight duct. When we add the turning vanes to that, it actually reduces the friction rate down to about 15 equivalent feet. So it allows us to, essentially, if we didn't use these, we would have to increase the size of the ductwork to overcome the friction.
So if there's a homeowner that's thinking about adding a zone system to their current system, are there considerations that they need to think about before they go forward with that? Are there red flags that, hey, this might not be a good idea?
So I feel like today when people think of zones, they kind of think of mini splits, and they think of, oh, I can have a thermostat in each room and I can turn rooms off. Zoning with conventional HVAC equipment is not that way. You can overzone a system. So as I said, you really want to try to uh, figure out what's the minimum airflow that the equipment can safely run on and try to make that your smallest zone. Um, so there's two different methods of zoning today. We have pipe dampers. So if you had a retrofit application, let's say you have a two-story house in the Highlands or an older home where the basement's unfinished, you can get to all the ductwork. We can go into that house and we can put dampers in each branch duct. And then we have one zone control panel, hook different thermostats to it. The zone control panel is the traffic director, if you will. So if it's a summertime situation and the first floor is comfortable, but the second floor still needs cold air, all those first floor dampers will close down. The system will continue to run and deliver air to the top floor. If you have a single stage system, meaning when your system comes on, it just runs at high speed. Ways to deal with that are bypasses. So you essentially take a duct from the supply to the return, and it has either a weighted, like a weight on it that would open up as pressure increases, or they even make ones that are pressure regulated with an actual pressure reading device. And then they monitor leaving air temperature. So they will overcome that inherent oversizing of the equipment by one, making sure the air that's leaving isn't too cold, and two, making sure that they can bypass the amount of air they need to, so that they're not trying to force all the air out of a small duct system. The most elegant way to do zoning is to use multi-stage HVAC equipment. The better zone controls will allow you to give the zones a weight. So you could say the first floor is 50% of the zone weight, the second floor is 50% of the zone weight, and then you could tell the control, don't go into high blower speed unless you have more than 50% of the zones calling. So that's a much more elegant way to control the capacity of a system. So I usually encourage people, I tell them that we can zone any system, but if you have a 10-year-old unit and we now add these controls to it, we're ultimately asking more of it. So we're probably going to reduce its life expectancy. Um, and if you are replacing equipment and you think you may do zoning in the future, I strongly encourage them to consider multi-stage equipment because it's going to complement the zone system much better.
So that's actually a good topic. If you want to just briefly explain, like, what is a multi-stage piece of equipment, whether it's a furnace or a heat pump, what does multi-stage mean?
Right. So I always kind of explain it by, if we come to your house to replace your piece of equipment, we are supposed to do a load calculation. If you already have ductwork in your home, we're supposed to do a block load. So we are essentially saying, okay, computer, you have this much wall and window that face west and this much east, north, south, and the wall is of this construction. It either has insulation or it doesn't. Essentially, we are computing how much heat loss or gain there is through the construction materials of the house. It doesn't have as much to do about volume, it has more to do about exposure. So when we do that load calculation, we say, how much energy does it take to keep your thermostat 75 degrees when it's 93 degrees outside? And it gives us a number. The problem with that is we know now that we are oversized most of the year, right? So we're sizing your equipment to theoretically heat or cool your house in the most extreme conditions, which makes it so we're oversized probably 75, sometimes even 90% of the time. So a typical multi-stage air conditioner would be about 65% of its capacity on first stage. And the idea behind that is, one, you are using less energy, but the other side of it is you're getting longer run cycles, which gives you better dehumidification, more even heating and cooling. In Louisville, Kentucky, I kind of tell people these are like heated leather seats. It's not necessarily a return on investment decision here because we still enjoy relatively low energy rates. But as far as quiet, better dehumidification,
Comfort.
more comfort all around, that's really what I think you're getting. And if you are going to do a zone system, I think it's a necessity. When homeowners are talking zoning, I always tell them I would not go any lower than this. So a multi-stage unit. The furnace is much the same thing. The furnace would be, first stage is roughly 60-65% of the capacity. You'll find it runs there probably 75% of the time. And then when it gets really cold, it kicks up into high fire. Other benefits of a multi-stage system is you're getting more out of your filtration system too. When your unit is moving a lower quantity of air across your filter surface area, the slower the air moves across that filter, the better job it can do also. So there's lots of benefits, of course it costs more, but in today's day and age, it's not twice. It's probably 20% or 25% more for a good multi-stage equipment or system.